Hey guys, today we are doing key features of functions. This is posted in Google Classroom, so feel free to go fill it out there, or you can print it off and do it that way. You are also welcome to do it on paper. If you choose to do it on paper though, make sure you go ahead and pause this video and draw this graph. That way when you reference your notes later, you actually have a graph to go with it so you know what you're talking about. Remember guys, at any time, if I'm going too fast or if you didn't understand something, you are welcome to rewind and watch that part again. You can pause it and catch up, whatever you need to do. So feel free to take these notes at your own pace. So for key features, you have seen a bunch of these before. We're going to go over them anyway. They also were in your vocabulary that you did a couple of days ago. So we are actually not doing all of these right now. I am going to split this into 2 videos because there is kind of a lot of content here and I want to make sure you really understand it. So we're going to do a few of these things in one video and the rest in the second video, which means you need to make sure you watch both videos in order to get all of the material. So this first video is going to include everything except positive, negative, increasing, decreasing, and constant. So we're going to save those topics for the next video because they are can be kind of confusing, and we're going to do the rest of them in this video. So we will start with x-intercept. Your x-intercept is where you cross the x-axis, so that would be here and here. When you write your x-intercepts, you always write them as ordered pairs. So it crossed at -6, 0, and 5, 0. Your y-intercept is where you cross the y-axis. That would be here. Again, as an ordered pair, this is at 0, 3. Next we have minimum and maximum. So a minimum and maximum you've kind of been taught before is when it does this, that's your max, and like this, that's your min. So notice that what this actually happens is when it changes from increasing to decreasing. If your function was going up and then it started going down, it made a max. If it was going down and then started going up, it made a min. So please try and get away from the idea that your maximum is your highest point and your minimum is your lowest point. That is not true. So when you were doing quadratics in Math 2, yes, that was true. But now in Math 3, we do cubic functions, which look like this. Notice your highest point is infinity. Your lowest point is negative infinity, but these still have what we call relative min and max. So it's not your absolute max or absolute min, but it is relative to its area. So in this area, this is still a max, and this is still a min. Even though this is not the highest point, and this is not the lowest point, it still was increasing and decreasing, which made a max, and then decreasing and increasing, which made a min. These are just called relative max and mins, which are the ones we're going to find. So because there's no absolute max or min because they go to infinity. So in this one, the example on the paper, maximum, I need to find somewhere where it goes up and then comes back down immediately. I actually don't have one of those. I go up, I'm constant, I go down. I don't have anywhere where I go up and come back down. So there is none here. And none is totally an option for these. Minimum, I did that backwards. It doesn't matter. They're both none. There's not a minimum either. So a minimum is when it goes down and then comes back up. That doesn't happen anywhere. So there's not a maximum or a minimum on this. Like I said, we're skipping increasing, decreasing, constant, positive, and negative. I'm going to do that in the next video. Domain and range. Domain, you might want to write this down, is when you go from left to right. So the left-hand side of the graph to the right-hand side of the graph. Range is bottom to top. So the lowest part of the graph to the highest. So let's look at this. If I'm going left to right, what is the farthest thing on the left? Notice this graph runs off the paper. So if you want to draw an arrow there just so you say, hey, this is going to keep going. This is going to remind me it's going to keep going. If it goes left forever, we call that negative infinity. If it goes right forever, we call that positive infinity. However, this did not go right forever. It stopped. And it stopped at 8. So be careful, it did not stop at -4. It stopped at 8. You're going to always use the number on your x value, on your x-intercept, sorry. And the reason we do that is because domain is all your x values. Remember, that was a vocabulary word, domain. Domain's all the x values, so I'm only looking at the numbers on the x-intercept. Range is all my y values. So this is bottom to top. What's the lowest this function goes? Guys, please be really, really, really careful. A lot of you are going to think the lowest this function goes is here, which is at -4. And looking at it, I can see where you would think that. But I also need you to remember that this line has an arrow on it and it goes forever, which means it does this. It goes down forever. This over here is lower than -4. So just keep that in mind, that this is going to keep going down forever. This one stops at -4, which means my range is actually -infinity because it went down forever. To, if it went up forever, that would be +infinity, but it doesn't. It only goes up to 3. 3 is as high as this function goes. Notice I did do brackets here, so anytime it stops at a number, you use a bracket, but if not, you can use parentheses. So that is domain and range, left to right, bottom to top. Then we have end behavior. That's probably the only thing in this video you have never seen before in your entire life. For end behavior, you're literally just paying attention to the ends of the graph. So for end behavior, I am looking what's going on over here. Remember, this went on forever. And what's going on over here. Okay. The first one says, as x approaches infinity, this just means the right-hand side of your graph. What is the right-hand side of your graph doing? Oops, sorry, guys. The right-hand side of my graph is over here. And the right-hand side of my graph stopped at -4. It's as far as it goes. And I know I'm using -4 and not 8 because it says as y approaches. Y is this one going to -4. And this one over here says as x approaches -infinity. That's the left-hand side of my graph. The left-hand side of my graph is going down forever. So we call that -infinity. All right, so like I said, save the other ones. They're in the next video. And you will scroll down or flip over to the next example. Again, if you are writing on paper, take a moment to pause the video to draw this graph, and then we'll answer the questions. So, doing the same ones we did before, my x-intercepts here are where I cross the x-axis. Let me zoom out a bit. I cross the x-axis here. That's at 4. 4, 0. You have to write them as an ordered pair. And I cross again here. That's at 7. So 7, 0. My y-intercept is where I cross the y-axis. That's here. Notice that's kind of in between two blocks. It's in between 7 and 8. I'll call that 7.5. My minimum, remember, we're looking at relative minimums. There are 2 spots where I go from decreasing to increasing. I was going down and I go up. That's here. And there's another one here. So I have 2 relative minimums. And unfortunately, these don't hit exact points. I had to get pretty close. This one's at -5.5 and 1.5. Usually these come out as whole numbers, but not always. And then I have another one at -5.5. Oops, sorry, that doesn't go there. 5.5 and -2.5. Like I said, these just didn't fall in pretty nice even spots, but usually they do. The maximum is where I go from increasing to decreasing. It makes like a hill. So I'm going up and then I go down. That's here. And this is at -1. We'll call that 8.5. So as long as you're close, I'm going to mark you right. Again, increasing, decreasing, constant, positive, negative are in the next video. So we'll go to domain and range. Domain, don't forget, is left to right. So left to right, if I go left forever, that is -infinity. And this one goes right forever, that's positive infinity. And range is bottom to top. So the lowest point this graph is here, which is at -2.5. and it goes up forever, so we call that infinity. All right, last ones are end behavior. So remember, end behavior, I'm literally looking at the ends of the graph. Those are here. So as x approaches infinity, that's the right-hand side. My right-hand side is going up forever, so we call that infinity. And as x goes to negative infinity, that's the left-hand side. So over here is left. That is also going up forever, so we call that infinity. All right, guys, make sure you watch the next video because it's going to fill in the other stuff that we missed.